Hey guys, how's it going? Mr. Mitchell here. In this video we're going to go over one long example to show you how to do problems involving the evolution of stars. Now if you haven't already done so, check out my previous video covering the theory on this topic, and that way you can apply what you learned in that video to this one. So let's get started. So in our one and only question, it says that the diagram shows one way of classifying stars. Each dot in the diagram represents a star, so all of these dots represent stars on our diagram, and we've got temperature in Kelvin on the x-axis against luminosity on the y-axis, where a value of 1 on the luminosity scale represents the sun's luminosity. So part A says, what name is usually given to this type of diagram? Well, I've put it in here just so we can see it while we're answering these questions as well, but this diagram is called a Hertzsprung-Russell diagram, or an HR diagram. Part B says that the stars are arranged into 4 main regions. Identify the region called the main sequence, giants, supergiants, and white dwarfs. So we're going to label on our diagram here what these parts are. We have the main sequence there, that is the diagonal line here. We then have the giants, which are over here. We then have the supergiants above them, and then down here we have the white dwarfs. C part 1 then says, in which of the regions on the diagram is the sun? Well, the sun is in the main sequence, so if we look back at our picture, then that is this sequence here, and the sun is thought to be about halfway along, i.e. halfway through its lifetime on the main sequence. C part 2 then says the surface temperature of the sun is approximately 5800 Kelvin. Explain why the scale on the temperature axis makes it difficult to identify which dot represents the sun. Well, the reason is that the scale for the temperature is logarithmic and is reversed. So if we look back at the diagram, you'll see that we have larger numbers over near the origin here, and we have smaller numbers over here, which is reversed, and it's logarithmic. So that means it's difficult to work out where the sun would be, but it would be over here somewhere on the main sequence. Part D then says, in which region would you find the following? So we've got a hot bright star, a hot dim star, a cool bright star, and a cool dim star. Well, for part 1, a hot bright star, that's like the sun, so you would find that on the main sequence. But a hot dim star you would find in the white dwarf region. A cool bright star you would find in the giant region. And lastly, a cool dim star you would find in the main sequence, i.e. that could be a star near the end of its lifetime on the main sequence. Part E says a star is cooler than but brighter than the sun. Part 1 says what can be deduced about the size of this star compared to the size of the sun? Well, the star is going to be larger than the sun, and that's because large stars tend to have a larger brightness, whereas they tend to be cooler than smaller, more compact stars. Part 2 says what region would this star be in? Well, this star, if it's bright but cool, as we said in part D, would be in the giant region. Part F then says that a star is hotter than but dimmer than the sun. Part 1 says what can be deduced about the size of this star compared to the size of the sun? Well, it's hotter than, so it's probably going to be smaller, and because it's dimmer, that means it's not as large. So we can say the star is smaller than the sun. Part 2 says what region would this star be in? Well, it's a dim but hot star, and as we answered in part D, that's going to mean it's in the white dwarf region. Lastly, part G says that the sun's nuclear fuel will be used up over time. What will eventually happen to the sun's position in the above diagram? Well, once the sun leaves the main sequence, it's going to move upwards to the giant region. So let's say our sun was around here. Once it gets to the end of its lifetime on the main sequence, it will move up to the giant region here. That's all for this video, folks. I hope you found it useful. If you did, give it one of these, subscribe, and I'll see you in the next one. Take care.